Buenas tardes. Tengo el gusto de ceder el uso del espacio virtual que tiene este Congreso Internacional al doctor Matteo Manfredi, que va a presentar a nuestra siguiente conferencista, a la doctora Linda Tadic. Bienvenido, doctor Matteo. Quienes lo conocen saben que es el coordinador de este Congreso Internacional, que formamos parte de un equipo colegiado. Y bueno, es un gusto presentarte, Matteo. Adelante, bienvenido.
Muchas gracias, Perla. Muy buenos días a todos, casi buenas tardes. Y bueno, ha llegado la hora de presentar Linda Tadic, que nos presentará una conferencia magistral sobre the relationship between digital audiovisual archives and the environment. Linda es fundadora y directora ejecutiva de Digital Bedrock, un servicio administrado de preservación digital que ayuda a bibliotecas, archivos, museos, productores, estudios, artistas e individuos a preservar su contenido digital. Tiene más de 35 años de experiencia liderando operaciones de preservación, metadatos y producción digital en organizaciones, diferentes tipos de organizaciones. Actualmente es profesora adjunta en el programa de estudios de archivo de imágenes en movimiento de la Universidad de California de Los Ángeles, UCLA, impartiendo cursos de gestión de archivos digitales, descripción y acceso a los medios. Anteriormente también fue profesora adjunta del programa de archivos de preservación de imágenes en movimiento de la Universidad de Nueva York. Es asesora de conferencias sobre gestión de archivos digitales, preservación audiovisual y digital, y el impacto ambiental y la preservación digital. Es coautora del libro de metadatos descriptivos para la televisión, Introducción al principio, y fue editora del manual de catalogación de imágenes en movimiento. Entonces, nada más que darle la bienvenida. Welcome, Linda. Welcome to our Congress, International Congress, and here's to you, the audience.
Thank you. Gracias, gracias. Buenas tardes. So I'm joining you from Los Angeles, California today. And thank you so much. I'm so honored that you invited me to present and join you today on your conference. My regret is I don't speak Spanish well enough or understand it. Otherwise, I would be attending every session. It's a wonderful program. Thank you so much for inviting me again. So while I will be speaking in English, I'm grateful that that the conference organizers translated my slides into Spanish. So let us see. So you will be able to see it, thank goodness, in Spanish. And but it is also being recorded, so you can also just look at it another time. I'm just making sure I have this together. All right, so I apologize in advance. You will see the slides in Spanish, but I have printed out my slides in English, so I'll be looking at them while speaking with you. All right, so let us begin. Whoops. Here we go. So I must begin, even though this discussion will be specifically about digital archives and the environment. First, I must lay the groundwork and just discuss the situation that we are all in, which I am certain this is not new to any of you. So we are living right now in the Anthropocene epoch. So just as in older epochs, maybe, the dinosaurs existed, the dinosaurs were killed by an asteroid hitting the planet. Well, we humans are that asteroid. We are the ones who are the main drivers for the increase in greenhouse gases and for the environment in which we are living in today. So scientists all agree that an increase of 2 degrees centigrade will result in extremely dangerous climate change. We will have the warmer ocean, which will have dead sea life, which means no food. The melting ice will flood coastal areas. And also then, as the permafrost then is melting, then it will release methane gas. And methane gas is 28 times, or releases 28 times more greenhouse gases than CO2 or fossil fuels. And also of a concern now, especially as we have just gone through 2 years of a pandemic, who knows what ancient bacteria will be released from that has been hiding underneath that permafrost for millennia. So this, the melting permafrost is something of great concern. We have severe weather already. We have stronger hurricanes, stronger cyclones. We have drought, which we're experiencing here in California. We have less potable water, which means less food. We will have starvation and suffocation. Suffocation, people can't breathe. There's not enough oxygen in the air, or it is so hot they cannot survive. We will have human migrations, climate refugees. We already have that. And there will be wars as a result of countries and regions fighting for the precious global resources. So thinking about from Paris, we all have in our minds Glasgow, which is still continuing this week, the COP26 conference. The first major one was in Paris 2015, and actually that is where I first gave my first version of this talk. It was at the EASA conference in Paris in 2015. But the objective in 2015 was to limit global temperature from rising more than 1.5 degrees centigrade from the pre-industrial area. And we need to limit that by the year 2100, by the end of the century. But we have already raised it by 1.1 degrees centigrade. With the current conditions, if nothing changes, we will reach 1.5 degrees centigrade in 20 years, by 2040. And pretty much the consensus is we're not going to make it at all with what is happening now. And the greenhouse gas emissions stay in the atmosphere for centuries. So even if all countries, all individuals, all companies, organizations stopped their greenhouse gas emissions today, it would still be increasing just because it stays in the atmosphere for so long. So that was in 2015, hoping to keep it at 1.5 degrees. The objective now is we've lowered our bar because we know we can't make that. So now we're looking to not raise it more than 2 degrees centigrade. But that increase there will result in extremely dangerous climate change. And we have to take drastic steps within the next 10 years. So we are all responsible for it. Our governments are, our companies are, our archives are, we as individuals are. So what can we do? Because the situation right now is where the amount of CO2 that is in the atmosphere today is comparable to what was in the atmosphere 3.6 million years ago in the mid-Pliocene warm period. And during that time, the ocean level, the sea level, was 23 meters higher than it is today. And the average temperature was 7 degrees Fahrenheit higher than today. But we are going to be reaching that goal that we do not want to meet. But we will meet that by the end of the century if things do not change. And to put that in perspective then, 3.6 million years ago, camels were roaming forests in what is now the tundra in Nunavut, Canada, up in the polar Arctic Circle. So we are headed towards that direction now. But let's now bring it back to us, and where do our archives situate ourselves in how we use and how we emit greenhouse gas emissions and how we use fossil fuels. So these categories here, the 6 categories, are the primary categories within the ICT, or Information and Communication Technology component for analyzing CO2 emissions. So the first one, as you can imagine, is energy use. And what I have here in red on the slide is where we directly intersect with our archives, with our work. So we have electricity that we use on premise, in our buildings, in our archives, but for storage of our digital files. We also, though, are using, if you use cloud storage, even though it is the data center's responsibility for the energy use that is using the energy, it is your content. So if you have content in the cloud, even though it's at another data center or in the cloud, it is still your content. So you have to accept that responsibility for your data. There is industry, which is from the companies that create the hardware that we use, the servers, the computers, everything that we use to keep our data alive. We have surface transport, the third category, which are the cars, the buses, the trains, how you get to work, how you have items shipped to you or you ship out items to others. We have public buildings, which would be your archives building, which emits greenhouse gas emissions, CO2. You live somewhere, and so that's residential emissions from your apartment buildings, from your homes, from your houses. We are emitting CO2, greenhouse gas emissions. And the aviation industry, obviously, from travel. and planes, and also if we ship things by plane. So these are the 6 broad categories for ICT for the technology part of greenhouse gas emissions. So bringing that down closer to home for you. So the percent within the ICT emissions, there are also then 3 subcategories. So you have end user devices. You are sitting at a computer, I imagine right now, attending your conference and listening to me. So it is expected that greenhouse gas emissions from your end user devices will actually decrease over time because the manufacturers are making them to be more energy efficient. The second category is streaming, your ISPs. So there are networks that are taking, so I'm sitting at my computer in Los Angeles and I'm on my home Wi-Fi network, which is then sending this stream out to across the network to a data center, which is then hopping my voice and my face around the world to data centers wherever you are situated. So that is from the streaming network that is then transmitting this. This will increase because of the increase in data. And just look at the pandemic period when people are working from home and attending virtual meetings and conferences. Then this obviously also increased in the streaming data. Then we have the data centers themselves. So again, I'm speaking here. This is on Zoom. It is being streamed on Facebook, I understand. So Zoom, Facebook, YouTube, all of those, they are sitting in data centers. So again, the network goes from my house to a data center in downtown Los Angeles where Zoom is located, goes across to another data center closer to where you can, hops along the way until it gets close to you. Now, the data centers, there's an increase in data that we're all generating and using. So the data centers, even though they also are becoming more efficient in their energy use and the hardware is becoming more efficient, just because there is such a vast amount of data, that energy use is increasing. So let's look to see about our archives. Your archives, you intimately understand the dangers that climate change present to your collections. Just the heat and humidity in tropical environments, which will get worse, that will contribute to the archives deterioration, just naturally, just from the moisture in the air, the heat and humidity. The rising sea levels will cause flooding during storms. So if you're along the coast, then your archives are in danger. It will overcome land over time. And then there are wildfires because of the droughts and the fires that are occurring, especially here in California. And I'll have an example later on in my presentation of other wildfires that destroyed collections. So this is how climate change can impact and endanger your collections. So you have physical collections at risk from natural deterioration just because magnetic media, audio, video, it just deteriorates over time. And there is climate change that is placing all of your collections at risk. So we have these 2 factors working together, which is making archives increasingly digitize their collections to save them, to preserve them, because the original physical carriers are at risk and are dying anyway. So these digital files are being created. And then you also have the born digital content that you are receiving in your archives to preserve. So all of that digital technology that we must use to keep our collections alive contributes to climate change. We have a circular relationship with the environment. The environment impacts archives through climate change, and archives also impact the environment through our actions. Because every action from individuals, organizations, companies, governments, cultural heritage organizations, we all impact the environment through our actions. And we, as archives, intersect with digital content. Our digital content intersects with the environment through the greenhouse gas emissions, through energy use. And that is something that is really obvious for us to recognize. But then there's also the direct toxic endangerment to people from the hardware, the video, the storage media for all of this data through e-waste disposal. How do we dispose of these storage devices? And we are also depleting the planet of natural resources as well by creating all of these devices. So we all had an individual carbon footprint. Because of our individual actions, we take responsibility for trying to do the best we can. We recycle, we try to take public transit, we install solar panels, we turn off the lights in our rooms, we do what we can as individuals to try to not impact the environment or to impact it as little as possible. But then there's this other term that I just read this past month, called the climate shadow, which I really appreciate is a bit more complex than just our carbon footprint, which is easy to define. And this term was written by Emma Patty in this blog piece, and there's a link there. So basically, it is where you do your individual actions, but in your daily life, in your work at your archives, you can have more impact on the climate. You can have positive or negative impact. You can it stretches out beyond just your individual footprint. So do you tell your archives, do you tell your universities, your organizations, what are we doing to have more policies for recycling our e-waste, for example? What are we doing to try to combat our greenhouse gas emissions that we are doing at our archive? How do you vote? Do you vote for people who will try to, to promote green technologies to impact climate change? Do you purchase items from companies that are offering you more green technologies? What do you do beyond just what you individually can do? And this is your climate shadow. So what can archives do to mitigate their environmental impact? And then how can archivists decrease their climate shadows? So audiovisual preservation has two parts, as I mentioned before. Archives must digitize analog magnetic media, that's the video and the audio for preservation. So you have digital files on data storage devices, which will be discarded as well, will be the original analog material. So what then happens with, so preserving the content, making it accessible impacts the environment through that destruction, the legacy video, audio that will be destroyed, the electricity use that you are using in order to preserve this content, and is the energy resources, are they dirty, like from fossil fuels, or are they clean, as in renewables? And then you will have to destroy the hardware and the media itself from the storage devices. They don't last forever. What will happen then after 10 years, let's say? We recycle it. Will it be incinerated? Will it be dumped in a landfill? So how much data are we actually talking about? So some hard numbers. So by the year 2025, it's estimated that the amount of data being stored on devices globally from all sectors around the world will reach 175 zettabytes. Half of that data will be stored in the cloud, but this is not including all of the data that might be sitting on legacy LTO tapes or on hard drives that are sitting on shelves, which then have to be refreshed, restored, so that those files can be used. So that will even increase more data. And there just is not enough storage media right now to store all of that data. And the planet does not have enough raw materials to manufacture our current storage media ad infinitum. Data storage doesn't last forever. And when the storage's useful life is over, they must be disposed of one way or another. So how long do electronics products live for? Well, there are two lives: initial service life, which is the original owner, and that can be 2 to 8 years. And then there is the second service life, which is, let's say, then that it is recycled through reuse. You have devices that you don't need any longer. You're going to upgrade your infrastructure or your storage. You can have sometimes that the devices, the computers, the hard drives, the servers, they can be wiped and cleaned out, and then those can be recycled through reuse. But ultimately, at the end of all these use, the devices will die. And then what do? They can either go into landfill, they can be incinerated, they can be recycled. Some of the parts of it can be recycled, and they can be unfortunately exported to other countries and become e-waste. Now, e-waste can contain heavy and rare earth metals and plastic. So what I want to focus on now is about considering the recycling potential of your storage media and devices. So these electronic devices, they have heavy and rare earth metals in them. That's used in making everything electronic that you have. Phones, computers, TVs, servers, hard drives, everything, magnets, batteries, all of it. Automobiles have heavy and rare earth metals, but only less than 1% of rare earth elements are currently recycled. Then you have the heavy metals, which are just toxic by their nature. So if these e-waste devices are just thrown into landfills, then these toxic materials will go down into the soil, which will then go down into the water level, and then it can impact, and that's where the toxic endangerment to people come into play. We are also depleting the planet of its natural resources through silica sand. So silica sand is what you have to have, this quartz type level of sand in order to go into the electronics. It isn't like you can go to the beach, to the ocean, get a bucket of sand and put it into your glass electronics. It has to be a special kind of sand. There is a shortage of that right now. Helium is used to make hard drives spin faster or spin cooler and use less energy, which is also a natural resource and is finite resource. Then there is purified water that is required to make microchips. So if there is a drought, there is no water to be purified to make the microchips. So we all know about recycling plastic as consumers. We recycle our, the cushions, there are plastic bottles, we do what we can. But the plastics that are used in computers, in video cassettes, in data tape, those are different formulations than our consumer quality of recycling, where plastic recyclers know how to, it's an established process. So it is more difficult. You can't just take apart your videotapes or your data tape or your computers and take that plastic to a plastic recycler. It has to go to special recycling. So let us just quickly have a review of the different types of data storage devices there are and what is possible to recycle or reclaim from them. So there are three types of storage devices. There is, for physical carriers, there's spinning disks, which are hard drives. There is data tape, like LTO tape. And then you have NAND or flash storage. So for example, your solid state drives or SSDs. And the cloud, even though people don't think, what is the cloud? It is just a way, you don't think about it, out of sight, out of mind. It actually is using a mix of these three types of data storage devices. So going through them one by one, first we have the spinning disk. Spinning disk as itself isn't using energy, it's just sitting there until you power it up, put it in an enclosure, put it in servers to actually spin it up and use it. So servers can use a combination of hard drives and solid state drives, but right now we're talking about hard drives. So when it is in the enclosure, when it is spinning, that uses a lot of electricity when it's in the servers. They spin very fast. So you have to have fans to keep them cool. Helium-filled hard drives can reduce energy by 23%, but as I mentioned just a bit ago, the helium is also a finite natural resource. Life expectancy, it usually is for the first service life is 3 to 5 years. Now, what can you recycle from these drives? Well, it has rare earth metals, it has plastic, it has aluminum, it has magnets in it. And so what can be recycled? So the manufacturers are interested in recycling. So you should know the three manufacturers of hard drives. There's only three. Even if there are different labels on them, the actual manufacturers are Seagate, Western Digital, which has HDST drives, and Toshiba. Those are the only three. And just in the second quarter of 2021, they shipped these three manufacturers shipped out enough devices, enough hard drives to store over 350 exabytes of data that were shipped out. So that is a lot of data. So it's a lot of hard drives, as I mentioned before, that there is a shortage of raw materials to keep making these forever and ever. And the manufacturers know this. Again, they're in the business of making money. It is in their best interest to try to, and they know that there's a limit in raw materials. It's in their best interest to try to find methods to recycle some of the materials from these hard drives. Now, it is hard for recyclers. What I've heard in speaking to different manufacturers and recycling facilities is they say it's hard to really recycle all the different parts of a hard drive. They call it death by screws because hard drives have all these screws. You have to take them out in order to get to the magnet in order to then recycle all the other parts. So they calculate the cost to try to do efficient recycling reclamation versus just shredding it and incinerating it. So the vast majority are just shredded and incinerated. If they can recycle them, the two elements they're really focusing on are the aluminum and the magnetic coating, which is a rare earth material. So I just want to quickly go through, because I know that you will see this later, so you can get these links. Some of these are international projects. just quickly some of the projects that the manufacturers are working on to recycle hard drives. So Dell, Seagate, and Teleplan, they developed a method to extract out some rare earth materials and also the magnets. And they have successfully put these new magnets and materials in computers and hard drives. So this is a successful project. Dell also has a recycling program. Again, these are more for consumer and small businesses rather than if you have thousands of drives, you would not be able to do this here. But here's a link. This is an international program. You can go online and see where you can drop off your materials. Now, Google, which as you can imagine has data centers around the world, and they also rent out space in other data centers. They are working with data centers to really try to find out how can we recycle material off of the drives that are more in enterprise use, enterprise meaning the data centers and large server environments. And when I saw this number, I was just astonished that 22 million hard drives age out, which means they're at the end of their useful time period for initial use and have to get replaced. 22 million only in North American data centers every year age out. And what do they do with these 22 million drives? So Google is working with them to try to find the technologies to reclaim the magnets because Google needs data centers and a data center runs on spinning disk and solid state. So they have to figure out a solution. So again, money talks. They want to keep making money, making business. So everybody, all these manufacturers and companies are trying to figure it out. HP, Hewlett-Packard, also has a program, which is an international program to recycle devices. You can go there to find something close to you. And Western Digital also will accept hard drives and solid-state drives from any manufacturer, but unfortunately, this is only in the US, and it's only 5 at a time. So it's very, very limited. It's really for consumers. So that was about hard drives. Now let's move on to solid-state drives or NAND flash memory. So all of your computers have solid-state drives inside them. They have no moving parts, so you can power them down when they're not in use, but they have a finite number of writes. They're very fast. These are faster in like retrieving and writing data than and making data move than the hard drives are, which is why you will find solid-state drives in your computers because they're running the applications, not necessarily for storage. So the electricity use is low to medium. And it can work in extreme environments. However, you would never use solid-state drives for storing digital preservation files because the data fades over time. Going into this, so just as an example of this, so if you're familiar with Chia cryptocurrency mining, so this is a notice that came out from Scaleway, which is a data center cloud provider in France. And their clients, the people who were renting out space, renting out their drives and solid-state drives, were running Chia cryptocurrency mining, and they were burning up and destroying the solid-state drives within like 2 weeks. And so this can happen if the solid-state drives are in constant use, constant writing, you will destroy them within a few weeks. Or even if you just have it sitting there inertly, the data just fades from it. So again, it is not a good preservation media. So if you're thinking about it, it's also very expensive. So you likely would not want to use it for digital preservation. However, you need to know then about how the life expectancy of these drives. So you can also plan for that and how to recycle them. So we have experienced a global storage media and computing supply chain storage. The first one is for this past year. The first one is the microchip and semiconductor shortage, which started earlier in this year, but it really had an impact starting in the spring. This is partly because there was, during the pandemic, the manufacturers slowed down production because less demand. Now all of a sudden there is a lot of demand. But then most of the semiconductors and microchips in the world are developed and built in Taiwan. And Taiwan has been undergoing a very severe drought, water shortages. So in fact, there were like individuals were told you can't use water on these days because they needed to use the water in these manufacturing plants for the microchips and semiconductors. They need to keep that going because again, they're very water intensive and it has to be purified water as well. So droughts around the world means fewer of these elements that go into our electronics just for our daily life and for digital preservation. And there has been a shortage of hard drive and solid state drives because, again, as I mentioned before, because of the Chia cryptocurrency mining, where people are just like gobbling up all of these devices, storage devices to run the cryptocurrency and killing them. So those were more traditional electronics. Now let's look at data tape. So data tape is another way to store your data. And so it has very low to medium energy use. And in fact, if you just have written data to tape and you put it on a shelf, it has no energy use except for whatever is in its storage environment. Manufacturers say there's a life expectancy of 30 years. However, really, you're going to be migrating that data to another generation, every, like, say, 5 to 6 years or so, every 2 to 3 generations. Now, the sad thing about LTO tape, in contrast to the hard drive manufacturers who are desperately trying to find a way to reclaim the materials from their drives, there really isn't an equivalent R&D effort from the data tape manufacturers, which is a shame. It does have some recycling parts. The plastic, the screws, is really simple as far as the physical technology of it. The tape that it's on, the data tape, is on Mylar tape, and so Mylar can be recycled. Again, but you have to scrape the data element off of the tape in order to do that. And they do not have the technology available right now to do that. So who are the manufacturers for LTO? So you have the tape. The tape, there are only 2 manufacturers, Fuji and Sony. So if you are buying LTO tape and it might say it is Hewlett Packard or Quantum on top of it, it's really Fuji and Sony tapes underneath it. And then the drives, obviously the tape is the storage medium, but you have to put that tape into a drive in order to write data to it or read it. There's only one manufacturer of drives, and that is IBM. So if you have an LTO tape library, tape robot, and it's from any of these other manufacturers, they're all using IBM drives. So there is always a problem when there is only a sole supplier for any device. So if you want to recycle, which you should, your e-waste, there are 2 international resources. So here are the 2 links for them, eStewards and R2. You can go to these websites and you can search for your region and see if there is any facility close by you that can do the responsible e-waste recycling. So for example, I just did a search on the R2 site for Mexico City and it listed 2 locations. Now you need to call them and make sure that they will accept your material, ask them what they will do for recycling. Will they take it apart? They can, but that's more money. If they shred it and then incinerate it, what are their incineration processes? Are they just like spitting out the off gases, the toxic fumes from the incineration instead of capping it? So you could talk to them and try to find out. Now let's talk about the cloud. So the cloud is basically you store your data on somebody else's servers. So cloud storage has its benefits and its negatives. So the benefits are you pay for what you use. You don't need to purchase all that hardware. You are not responsible for the e-waste when it ages out and you get new devices. Using the cloud can be helpful, again, in economies of scale, because the cloud provider will be managing all of that electricity, the air conditioning, the power, the hardware. So instead of having hundreds of different organizations doing it all themselves, it's more efficient to do it within a cloud environment. It can possibly optimize electricity, but again, in the power, that is just a maybe. The nice thing too about cloud storage is, as I'm sure that you all do, if you can provide access to some of your collection online, then that's going through cloud, data centers. And so instead of people having to come to your location, to your archive physically, they can see your content and access it remotely. So there is a trend with archives and universities and businesses that are trying to be carbon neutral. And carbon neutral means where they are trying to have their physical plant or their organizations be, well, we have zero, the amount of off-gassing or greenhouse gas emissions we create is negated by what we are not using, what we're bringing in. So they say that we're using the cloud and that helps make us to be carbon neutral. We're using other cloud storage. But really what that means is you're using someone else's carbon. It is still your data that's sitting in somebody else's cloud storage. So you are not absolved of responsibility. So let's consider, for example, you're a cloud provider, the data centers. energy source? Is it dirty from coal, from fossil fuels, or is it coming from renewable energy? Data centers use 3% of the world's electricity, and 10 years ago it was only 1%, and in fact it's going to be increasing much more in the coming years. Now, most of the major cloud providers, they say they are going to go towards 100% renewable energy. Some of them are even building solar farms, wind farms to try to have renewable energy for their dedicated data centers, and they share that energy with the region around them. But the vast majority of their servers for these data centers, they are renting from other data centers. So thinking about where are the data centers in the world? So this is a map, Baxtol.com. It gives you a graph. Of course, there are many countries that are not represented in this map, and there are many more data centers than represented in this map, but this at least gives you a sense of what is available, what's out there. So I did a search on this website for what are the data centers in Ecuador, and it only came up with 2, and there are probably more, but that's all that was on this website. One is a university, one is the Telconet data center. So then I started thinking, which is what you want to think, well, what are the energy sources for these data centers? What is the possible source? So again, this is the information I found. I am sure that you have much more localized information. But what I found was that the energy in Ecuador the vast majority is generated by hydroelectricity, which is a renewable source. If there is water, if there is a drought and the water goes down, is decreased, then that immediately impacts your hydroelectricity, your energy source. We have seen that here in California and on the West Coast of the US, where there's, in particular, there is this one city in Central California which relies on hydroelectricity for its energy, for its electricity. The dam that is providing that electricity, there's a water shortage, there isn't enough water. They know that within a year that water will be gone, and what is going to be their electricity source. So this is again how climate change impacts then our data, what we use. So back to the immediate question then, what can archives do to mitigate their environmental impact, and how can archivists decrease their carbon shadow? So let's discuss about some concrete action steps. And again, the idea about decreasing your climate shadow is trying to encourage your organizations then to take some of these actions. So one of them is like where you think about your appraisal policies, which is what archives do. What do you need to say? What should you acquire? What should be retained forever for permanent retention? If you don't need to keep all of these digital files for permanent retention, you could then retain them for a specific period of time, put them onto maybe less energy intensive storage like data tape, something that isn't powered up, and then ultimately delete them if you don't need to keep them forever. When you are digitizing your content or acquiring digital content, does it need to be at the highest possible resolution? Because high resolution, which is wonderful, but it makes big files, and a lot of big files makes a lot of storage that you need to manage and administer. So if you want to create the best quality or best resolution files that you can, do you need to store them online? Again, store them offline, store them on a device that is not connected to power sources, so you're not using electricity. Think about how you can recycle this media over time. So let's just think of here, this is an example of where you might have heard about this in the spring and May. So in Cape Town in South Africa, there was a wildfire that was triggered by, I believe it was a lightning strike in the hills outside where this university is based. And so the fire reached the library. It had severe damage to the library. And in fact, they reported there were 3,500 irreplaceable films that were on that main floor there that were stored off the main research floor, and they were destroyed. So there was a call that was put out to researchers around the world who had come to the university library to create digital copies for their own research. And they said, if you have content that you digitized, from our library, please will you let us know so we can, even if it's low resolution copies, because having a low resolution copy is better than nothing. So if an archive has limited resources and budget, it's better to save the content, focus on the content, not fetishizing the digital file. It might not be the ultimate the best possible quality resolution, but it is better to have a copy of the content than nothing. So a preservation action, you probably are familiar with checksums and running fixity checks over time according to a schedule to be sure that the files are safe and that the bits are healthy. So depending on the storage medium and system, if you know that the files were written well and they are just stored offline, the checksums were checked them, you store it offline, do you really need to check it so frequently? Maybe not quite so frequently, which will then use less energy over time. So using less energy is related to storage. It means that try to avoid using spinning disks as much as possible. So I recommend using or applying hierarchical storage management policies, or HSM policies, and your IT people will know what this means. It means where you store your large and infrequently accessed files, perhaps offline, on storage offline on data tape, for example, only keep online at tier 1 the files that you need to have constant or immediate access to. Just remember that spinning disk, those servers, takes 26 times more energy than storing your files offline on data tape. So just a quick slide on Hsm tiers. So tier 1 is online. Those will be the files that you need to have constant access to. Tier 2, which usually archives, in our, communities, we go from 1 and 3, but the tier 2 is nearline, which means it could be an environment where you have both data tape and also server all connected together. So you keep the files on data tape, the robot pulls out the tape, puts it in the slot, you read the file, it takes a little bit longer. But again, most archives are doing tier 1 and tier 3. Tier 3 being you store the files offline. You store files you don't necessarily have constant use to. You keep them on tape, on spinning or hard drives, they're sitting on a shelf offline, and you only get them when you need them. And you can use cloud storage as part of this HSM policy. So for example, you could keep the infrequently used, your tier 3, and really, really, really cold cloud storage that you don't really need to access at all. And they're using tape too. That's the secret with cloud providers, that like Amazon, Glacier Deep, and the others, they're really storing files on tape. So again, on to using less energy. If you store it on tape, don't migrate it every year. Don't migrate it to the new generation every time it comes out. Just be thoughtful. As long as you have the drives and the underlying infrastructure to be able to read those older generations, then you are fine. And you will have to recycle the old data tape through destruction, unfortunately, not through reuse. Hard drives you can recycle through reuse if the data is wiped. Data tape, no, because it has a finite number of reads. And if you are storing, if you have servers on site, then you don't need to keep it as cold as possible. It can be a little bit warmer, higher temperature than what was standard in the past. Using less energy also is by if you can. Again, all of these are if you can in your situation. They're just general recommendations. Turn off any unused servers. If you have servers, if it's possible to set it to go into inactive mode, if it's not in use, then that will decrease the energy. Use virtual machines. So you have one server that is divided into virtual machines. So you can have several applications running on one server, which results in fewer servers that you'll have to replace or recycle. Use the cloud for some applications, but again, look and see what, if you can identify, what is the green record? What is the good energy? What kind of energy are they using? And if you are actually using a data center for your own like private cloud, you know where the files are, again, question the energy source of where that data center is getting its energy from. If you can, this is only available in a few locations, but purchase clean energy if you can, if you have a choice of your energy supply. Purchase hardware that is energy efficient, and also try to purchase recycled devices. So for example, what we do is we will purchase recycled servers, the box, and we will put new drives inside them. So there are different things you can think about in using recycled materials, recycling by reuse. Upgrade the servers by upgrading the drives, not the entire box, as I just gave that example. The box itself, the server box, is recycled, it's reused, but the drives in it are new. Recycle by reuse when possible, and recycle the data tape and hard drives with vendors who strip out the parts if you can afford to pay, because you'll have to pay for that. Or if they are shredding and incinerating, just verify their incineration process. And what are they doing with the off-gassing that is coming out from incineration? But then us as individuals, what did we learn from working and living during this whole pandemic period, and how can we reduce the climate shadow? You know, work from home if it's possible, as many of us have had to do. That results in not only, you know, does it save our lives from a pandemic and getting sick, but also the less transit use, less auto emissions, which is good for the environment, but also, again, money talks. If the oil companies, if the gas companies, the power companies see like, there's less demand for fossil fuels, for gas, then they will invest more money into renewable energies. And this is already happening. It's been happening for some years. Are not using fossil fuels then tells them, okay, nobody wants it anymore. Let's go to what people do want, which is renewable energy. Hold remote conferences as you are here with this conference. On one hand, we are really tired of this. We want to see each other in person in 4D, you know, three-dimensional bodies, and also in movement in front of us. We miss each other. But on the other hand, these remote events help us then to attend more events, you know, than would be possible if we could only go in person. And online events are more, there's just no way around it. They are more environmentally friendly than everybody traveling to go to a conference. So we just need to find a good middle ground when this pandemic period is over. So I thank you so much for your patience and for your attention. And I hope that, you know, if the slides interest you, you can read them later. You know, I know that's a lot of information. And just thank you so much for inviting me to your conference.
Thank you very much, Linda, for your speech. Really interesting, and I'm sure that our audience enjoyed so much the information that you shared with us, and really thank you again. And well, now I have to change language. Bueno, entonces, otra vez gracias a Linda por su charla, por su ponencia realmente impresionante sobre una temática que realmente cuando asumimos el reto de presentar este congreso, nos parecía realmente una temática difícil de abarcar porque es totalmente, estamos en la actualidad, en un mundo cambiante, y el tema del cambio climático casi no se percibe dentro del mundo de los archivos, y en realidad a lo largo del día de hoy y del día de ayer, bueno, hoy hemos visto esos vínculos existentes entre los archivos y el impacto ambiental que pueden tener y sobre todo los archivos audiovisuales y sonoros. En este sentido, pienso que normalmente cuando uno sale de un congreso, se plantea a veces más preguntas de las respuestas que puede tener en un congreso. Sin embargo, con este congreso, más que preguntas, todos podemos compartir una sensación que es el compromiso que tenemos que asumir y el reto de aquí a los próximos años para encontrar soluciones sustentables para la mejora de la energética y del impacto ambiental que pueden tener los archivos audiovisuales y sonoros, y no solo estos. Entonces, yo agradezco a todos los ponentes que hemos tenido en el día de hoy